dissipation strategies, and then a few topics on the reduction of power dissipation, both dynamic as well as static. And lastly, I shall conclude with a few research dimensions. Now, let us have a glimpse of India's semiconductor scenario today. It is seen that around 51% of the India's electronics industry comprises of mobile are mainly focused on mobiles and wearables. Every year, uh, India is investing around 51% on mobiles and wearables, then followed by 20% in IT design, then consumer electronics, automotive, aerospace. So, what if India can manufacture a large amount of such products in India? So, and recently, several attempts have been taken to develop such products in India and make India self-reliant and economically growing. So very soon, India is expected to see in one of the top 10 in semiconductor manufacturing countries. Now we are speaking of semiconductors. Semiconductors itself means conductivity lies between metals and semiconductors. So there has to be the semiconductor present. The basis for design is metal oxide semiconductors. Though today, with the development of semiconductors, MOS, TFET, FinFET, all have been developing slowly, and research also has been slowly going on. But the MOS is the primary and the basic design, basic unit, functional unit of any semiconductor chip. Okay. So we have give a glimpse of this MOS, metal oxide semiconductor. It is basically a field effect transistor where there is a voltage that will determine the conductivity of the device. Now we are using MOS, not BJTs. Yeah, MOS truly in terms of power, MOS is more power efficient, as well as MOS occupies lesser area than BJTs. So MOS will be having any MOS structure basically will be having four terminals. Source, body, drain, and gate. So the drain is that source is that terminal. The source is that terminal of the MOSFET structure that can actually give rise to the charges that are happening, that are charges that are occurring in the device. That are occurring in the device. MOS is that are charges occurring in the device. And then there is a gate to control the current flowing from the source to the drain. So in simple sense, we can say that it is like the tap we switch on, which common example is the water tap which we switch on, where water tap will be the source and our bucket will be the drain, and our gate will be the speed with which we are turning on the water tap. This is just a
Farhana, sorry to disturb you. You please slideshow your.
Ma'am, I'm showing the screens, ma'am. Is it not visible, ma'am?
No, it is visible, but it is not a slideshow.
Okay. So sorry. Ma'am, is it visible now?
Ma'am, you can make it for full screen.
F5 it's done, sir. Is it visible now?
Ma'am, you have to change it as to like duplicate view rather than like extended.
That is not functioning actually. I tried once again. Just
Ma'am, I guess you can use presenter view.
yes, yeah. Is it visible now as full slide? Full screen? Is it visible as full screen now, ma'am?
Presentation stopped, ma'am, actually.
No, ma'am.